Okay, so this is part of the review for your it's the pre-calculus course in high school, but basically the fall semester is all college algebra. So what we have here is actually some pretty nice little problems to start off with. Talking about interval notation and the line graph. So this one says that x is greater than positive 2. So if we're going to write this on a line graph, right, here's positive 2. Greater than gets an open circle, and we shade everything to the right because these are all the numbers greater than positive 2. So as an interval, that would be parenthesis, positive 2, and then all the way out to infinity, which always gets another parenthesis. Okay, our second example here, we have negative 3 is less than x, which is also less than 5. So this is a closed interval. Right, so from negative 3 to positive 5, they both get closed dots on their points because they are included or equal to, and then shade everything in between. So this one as an interval is going to use brackets because brackets mean include this value in your interval. From bracket negative 3 to bracket 5. And then our last one here, x is less than 0. So we put a 0 on the screen, an open circle, and everything to the left of 0 is less than it. Or x is bigger than 5, so we put a 5 on the screen. We put a closed dot because it's equal to, and then everything to the right. So this will have two intervals, the interval from negative infinity to 0 with a parenthesis, union with a bracket 5 to infinity. And it gets a parenthesis. Okay, so those are your intervals. So the second part is asking about the domain. Now this is a rational function. So for all rational functions, your restriction is the denominator cannot be 0. So we're going to set 2x or x squared minus 6x or minus x minus 6 equals 0, which factors to x minus 3 and x plus 2. Okay, so neither one of those two factors can be equal to 0. So that means x cannot be positive 3 and x cannot be negative 2. So these are the two numbers that must be restricted from your domain, as in you can't plug them in, because if you do, they'll give you a 0 in the denominator. We don't want that. This next one is a radical. We cannot take the square root of a negative, so we have to make sure that everything underneath the radical will always be positive. So 4x minus 2 has to be bigger than or equal to 0. I guess non-negative would be better. So 4x has to be bigger than or equal to positive 2. So x must be bigger than or equal to 1/2. Okay, so as long as x is a number larger than or equal to 1/2, you will always get a positive value underneath your radical. Okay, natural log. This one you're just going to have to memorize because there's nothing really we can do. We can't, once again, take an equation of a negative or 0. So what's going to happen is x has to be greater than 0 for all log functions. In this case, this is a natural log function. It is a log function. And number 7, we have ourselves a quadratic. Quadratics have no restrictions on them whatsoever. So all reals is your domain. There are no restrictions on these polynomials. So all real values. Okay, and there's the first little set.